Focused flood inundation in North America. Flood hazard is a critical issue in many states of U.S. According to the study of Union of Concerned Scientists, 1 million Florida homes will be at risk of chronic floods by 21,000. Forecasting flood inundation is therefore of great significance for the sake of better land use planning in ahead and resources management when in emergency. There has been a lot of methods on flood prediction, for example, ArcHydro tools in the mapping software ArcGIS. However, it requires hand drawing of center lines of river that is highly possible to cause significant error, and plus it is very labor intensive. Application of a machine learning model is then an alternative, because people rely on the computational power, which is extraordinarily considerable nowadays, to mathematically optimize the pattern catching process. Flood inundation varies from place to place due to unique geological and land use conditions across space. Therefore, in order to focus the flood inundation in Nashville, Tennessee, we use a comparable city, Calgary, in Canada. Both cities sit in an urban content with a river crossing through. Our goal for the model is to build a machine learning model with accuracy more than 0.8. So, for the model, first, we create a fishnet of grids with side length as 100 meters and apply it on the Calgary flood area. As the dependent variable, if the majority of the grid cell is in the flood area, then it gets value as 1. Otherwise, the value is 0. For the independent variables, we try to be selective on features by applying domain knowledge. We got 5 independent variables. There are numeric variables as distance to open water, distance to flow accumulation, distance to steep slope, and distance to steep slope derivative. And there is one factor variable as the land cover. It's worth mentioning the distance to steep slope derivative. Higher the value, bigger the gap between the slope of the area and the neighbors around, indicating either a plateau platform or a steep valley. The steep valley is a highly possible area for flood inundation. 75% of the Calgary dataset is picked randomly to train our logistic regression model, and then the model is applied on to the rest 25% of the dataset. Our threshold for the flood area is 50% of possibility. The results shows in the confusion matrix that statistically, our model reached an accuracy of 0.936, which is higher than our expectation as 0.8, indicating a big success. The blue area, as true positive, are areas predicted as flood zones and actually are flooding. This is the area we want to optimize for saving time and money to prevent flooding hazard. The yellow, as false positive, are areas we fail to predict flooding. These areas should be minimized in order to reduce properties and life damage. Finally, we apply the model on Nashville. The flood inundation forecast map looks like this. So, as for the arrows, we will deep dive into the geological and constructed conditions alongside flood area in both Calgary and Nashville to get domain knowledge for new features. That is all for our presentation. Thanks for watching.